Rational graphs. Okay, to start us off, we're going to find our x-intercepts. To find the x-intercept, you got to plug 0 into the y, and to find the y-intercept, you got to plug 0 into the x. So for our x-intercept, let's plug in 0 for the y. In this case, the y is f of x, and this is what we got. This is what it looks like after we plug it in. When we simplify, first thing we're going to do is multiply both sides by the denominator, which gets rid of the denominator. Now you have a negative x equals 0, which is 0. Next, let's plug in 0 to the x. This is what it looks like when you guys plug the 0 into the x. On the top, we have a negative 0, which is just 0. On the bottom, we get a negative 16. After you get that, let's see, we get a 0. And that's our conclusion. That's it. This one right here, when we plugged the 0 into the y, we got 0, 0. When we plugged 0 into the x, we got 0, 0. So our only intercept, so both x and y intercept, is 0, 0, which we know is the origin. Next, let's try to find our vertical and our horizontal asymptotes. To find the vertical asymptotes, we have to find the excluded values. So we're going to take the denominator, set it equal to 0, and solve it. Because it's a quadratic, we're going to factor, and we're going to use our two factors and use the zero product property to find out what our excluded values would be. So you set each of the factors equal to 0. You solve, you get x equals negative 4 and x equals 4. And those are the two values that the denominator cannot be, because if it was one of those values, if the x's was negative 4, or if the x's were 4, you would get a 0 on the denominator, and then you would have no solution. You can't divide by 0. Okay, so these are our vertical asymptotes. Let me label those bad boys. And then let's find our horizontal asymptotes. Now for our horizontal asymptotes, there's 3 different scenarios. One of those scenarios is when the degree of the numerator is smaller than the degree of the denominator. The next one is when the degree of the numerator is equal to the degree of the denominator. And the last one is when the degree on top, is greater than the degree in the denominator. If this is the case, then you don't have a horizontal asymptote. These two right here are horizontal asymptotes, and they're really simple to find. This one is a straight y equals 0, and this one, if you have this scenario, you just take the leading coefficients and you divide them to find your horizontal asymptote. And this one is a little bit more complicated. It's a slant asymptote, or it's a parabolic asymptote. There's a lot of different types of asymptotes. In order to find that, you would have to divide the numerator by the denominator. But it doesn't look like we're going to have to do that. Our degree of the numerator is 1, and our degree of the denominator is 2, and then the degree of the numerator is smaller than the degree of the denominator. So, like I said before, we know that the horizontal asymptote is y equals 0. Next, let's go down to the bottom of the page to do the rest. All right, here's our function. I just didn't want to forget it because we can't see it now. The next thing that we're asked to do is to find the intervals of an increasing function. I'm going to choose to do this after graphing. So let's skip it for now. Let's find symmetry. In order to find symmetry, if there's any symmetry, we're going to plug in a negative x. Some people call this the negative x test. And the negative x test will tell you either if the function is even or if the function is odd. If the function is even, we have symmetry about the y-axis. If it is odd, we have symmetry about the origin. Okay, so let's see what happens. The top, we have a negative x, so now it's a positive x. And there's nothing else to simplify after that. The bottom, this one goes negative x times negative x, which you guys know is positive x squared. So check it out. We know that if we plug in a negative x, we get the opposite of what we started with. We get the opposite. That's what that negative is, of what we started with. See, I can rewrite this because it's more understandable. Here, let me show you guys. I could take that negative out of the numerator and just throw it out in front to help you see that this is a negative and an ugly fraction. Over here, it's a positive and then ugly fraction. So we can see that this is the opposite of what we started with. Therefore, we know that there is symmetry about the origin, because this is an odd function, because f is odd. All right, so now let's bring in our other information from our other questions. We have our intercepts, our asymptotes, and let's put them on the graph. And so we have our intercept right there, and then we have our asymptote, a vertical asymptote right there, a vertical asymptote right there, and there's our horizontal asymptote. Now, we have 3 sections where we have to figure out what the heck is going on. What is this graph doing? Okay, so when we look at these different sections, sometimes it's really helpful to know what it could look like. In the first section, we can have a line right there or right there. Okay, it could be on the top of the horizontal asymptote, or it'll be on the bottom of the horizontal asymptote. In the middle, we could have something that looks like this or like this. And then on the right side, the positive x side, we can have a line on top or a line on bottom, just like the left side. Also, for the middle, we actually can have parabolas. We can have one that goes up and one that goes down. Okay, so we have a lot of options here. Let's go ahead and do this. Now, what you could do is you could pick an x value in each section. Okay, so we have 3 sections, this section, this section, this section. You can pick an x value in each section and plug that in and see where the point is. If the point is positive, then you know you're going to draw a line up here. If the point is negative, then you know you're going to draw a line down there, so on and so forth. You can do that for the rest of them. For the middle section, you might have to do a negative one and a positive one because you don't know if this just touches it and bounces off or if it actually goes through it. But let me teach you guys a little bit about reciprocal functions really fast so you guys kind of get used to the way they look. So really quickly, I want to show you guys 1 divided by x. Okay, this is a parent function. All right, it's known as the reciprocal function. This is what he looks like. You'll notice that there's a horizontal asymptote at y equals 0, and then you have your vertical asymptote at x equals 0. If I threw a squared on the x, this is what it would look like. Both sides would be on top of the x-axis, but the asymptotes stay the same. Look at what happens when I put an x up here. This is actually kind of like what we have going on. We have our leading term is x on the top, and on the bottom, it's actually a negative x. And on the bottom, we have an x squared. So if we threw a negative on this, notice that this looks exactly like, first of all, it looks exactly like 1 over x. And that's because if you were to simplify x over x squared, you would get 1 over x. So what would happen if we put a negative on the x? It would flip it. It would flip the whole thing. You could put the negative on the x, or you could put the negative out front. It doesn't matter. It does the same thing. Now in the denominator, we have a minus 16. And so when we put that minus 16 on there, I want you to notice what happens. Oops, I want to stay on the denominator. Minus 16. Okay, look at what happens. Now we have our 2 asymptotes. We have our asymptote at negative 4. That's right there. And we have our asymptote at positive 4. And look at that. Look at that. We have this kind of looks like the x squared shape right here. This is what our function actually looks like. But if we went back to where we're at right here, if we kind of had that in the back of our head, we're thinking, all right, I see the leading terms right here. Those are the ones with the highest degrees. It's just negative x over x squared. Because you see this, hopefully you're thinking this. Okay, so that means we're going to get those 2 lines, the top left and the bottom right. And then the reason why you would know the middle is going to go like this is because the function usually almost always does opposite sides on the vertical axes, vertical asymptotes. Okay, so because this one goes up, this one's going to go down. Okay, all right. Now, this arrow right here is here because now we have to find our intervals of increasing. So we're reading the graph left to right. That's the direction we're going. And so when we go left to right, what is our graph doing? On the first line, the first part of the curve, it looks like the graph is going up, and that's true. And then on the middle part, the graph is also going up. And then the last part, the graph is going up. So it looks like everywhere this graph is increasing. But we can't say negative infinity to positive infinity. We have to break it up into intervals because at negative 4, nothing is happening. And so we can't just say negative infinity to positive infinity. The first interval will be negative infinity to negative 4. Okay, that'll be way over here to negative 4, and we put parentheses around both. The next one's going to be from negative 4 to 4, and the last one's going to be 4 to infinity. And that's how you do it, guys.